For complex manifolds, the distance is always like real, essentially. But for complex Riemannian manifolds, you calculate the distance essentially like you would in like general relativity. But because there are like complex numbers, it can get a bit confusing, but it doesn't really matter. Essentially, when you like are trying to find the lengths of a vector in general relativity, you take it, you multiply it by the metric tensor in order to make it like a covariant, and then you take the dot product of it, and it's the covariant and contravariance like solves together to get essentially the absolute value of that vector. If you want to find the lengths of that, you basically just take the square root. Everything before the like square root part is like still like perfectly well defined on like complex Riemannian manifolds. The square root part leaves an ambiguity of a plus or minus 1 in the result. So going back to the like complex 1 sphere, if you wanted to find what the distance between like some part over here and like z equals 0, then because of that the singularity at z equals 0, that's not like a problematic black hole like singularity, it's a coordinate singularity. But despite being a coordinate singularity, it's actually impossible to remove it.